Imagine this for a moment. You are standing a safe distance from a volcano, a magnificent and powerful giant of the Earth. The air is warm, and you can hear a low rumble, like the planet itself is clearing its throat. You are watching a slow-moving river of glowing orange-red rock ooze down the mountain. It's mesmerizing, isn't it? Science is often beautiful. But then, a small bubble in the flow pops, sending a tiny spray of molten material into the air. Two small, seemingly harmless drops, no bigger than raindrops, arc through the sky and land right on your arm. The world seems to slow down for a split second. What happens next is not like a scene from a movie. It is instantaneous and violent. There is no moment to think, no time to react. The sensation is not just hot in the way you might understand it from touching a hot stove, spilling a cup of coffee. It is an immediate, explosive, and overwhelming shock. Your body's nervous system would fire off every alarm bell it has, all at once. So, what is this stuff we call lava? It seems like something from a fantasy world, but it is very, very real. Lava is simply magma that has erupted from a volcano and reached the Earth's surface. Deep inside our planet, the rock is so hot it melts into magma. Molten rock, crystals, dissolved gases. When a volcano erupts, it creates a pathway for magma to escape. Once it's out in the open air, we call it lava, the Earth showing us what's inside. Now, temperature, where the danger comes from. Lava is incredibly, unbelievably hot. About 700 to 1,200 degrees Celsius. That's roughly 1,300 to 2,200 degrees Fahrenheit. Water boils at 100 degrees Celsius. A pizza oven reaches around 260 degrees Celsius. Lava is many, many times hotter than that. It glows brilliant orange, then dull red as it cools and hardens. The danger of lava comes from this immense thermal energy. Let's get into the science that superheated drop of lava makes contact with your skin. Your skin, your entire body, is mostly water. About 60% of you is H2O. The first thing lava encounters is that water. The heat is so intense it instantly flashes water to steam. This is called the Leidenfrost effect. For a very brief millisecond, a tiny cushion of steam might form, but the lava's temperature and weight overcome it almost instantly. The result is a burn unlike any other. We classify burns in degrees. First degree, a mild sunburn. Second degree, blisters. Third degree, destroys full skin thickness. Lava goes beyond that. Fourth degree, heat travels deeper. See diagram. Heat continues into epidermis. Dermis fat muscle bone cells are obliterated. Their water explosively turned to steam. The lava begins to cool as it transfers heat to you. It quickly hardens into black, glassy rock. But the danger isn't over. The hardened crust stays incredibly hot, trapping molten center. It sticks to your tissues, releasing thermal energy long after contact. It is a full-blown medical emergency. The immediate localized damage is just the beginning of a cascade of problems your body will face. The primary and most obvious issue is the severe burn itself. A fourth-degree burn that goes through skin fat and muscle is a catastrophic injury. The body's protective outer layer is gone, leaving it wide open to infection. The destroyed tissue, called eschar, is dead and will need to be surgically removed for any healing to even begin. This is not something that can be treated with a simple bandage and some ointment. Beyond the burn itself, a person would likely go into shock. There are several types of shock, and this situation could trigger more than one. Hypovolemic shock can occur as the body loses fluids through the destroyed skin. Neurogenic shock can be triggered by the extreme, overwhelming pain signals sent to the brain. This state of shock is life-threatening. The body's circulatory system can start to fail. It can be hard to wrap our minds around just how hot lava is. Numbers like 1,200 degrees Celsius are so far outside our daily experience. So, let's compare lava to things we know. Your home oven might reach around 260 degrees Celsius, about 500 degrees Fahrenheit. Lava is more than 4 times hotter than your oven. Imagine the heat wave when you open an oven door. Now multiply that many times over. Marketing visual. Comparative thermometer chart. Oven, campfire, aluminum melting point, and lava. Fun cartoon thermometers. A wood campfire burns around 600 degrees Celsius, about 1,100 degrees Fahrenheit. That's hot enough to leave a nasty burn if you touch a glowing ember. Lava is about twice as hot as a campfire. Aluminum melts at around 660 degrees Celsius, about 1,220 degrees Fahrenheit. A lava flow could easily turn an aluminum can into a puddle. The hottest part of a candle flame can reach roughly 1,400 degrees Celsius, hotter than many types of lava. So why can you pass your finger quickly through a candle flame without getting burned, while lava would cause instant destruction? The answer is heat capacity and density. A flame is thin gas with little thermal energy. Lava is dense molten rock that holds massive heat. It's like getting hit by a ping pong ball versus a bowling ball at the same speed. Volcanoes and lava are terrifying, but they are also incredibly cool. Let's take a break from the scary stuff and look at some amazing facts about these geological wonders. Did you know that the word volcano comes from the Roman god of fire, Vulcan? The ancient Romans believed the island of Vulcano, off the coast of Sicily, was his personal forge, and the eruptions were from him making weapons for the gods. Pahoho, pronounced pahoihoi, is smooth. Aa, pronounced aa, is the opposite. The largest volcano we know of is Olympus Mons on Mars. It stands nearly 22 kilometers high, which is almost 3 times the height of Mount Everest. Lava flows can create brand new land. Now let's tackle some common questions people have about lava. Can you poke it with a stick? The answer is yes, but only with a very long stick. Geologists use long steel poles to sample or measure flows. The stick will get extremely hot. It's about 3 times denser than water. You would not sink, you'd land on the surface. How close can you safely get to lava? Main dangers: toxic gases. Tourists must obey barriers and stay hundreds of yards away. While we hope you never ever have to use this information, understanding basic first aid for severe burns is important. If someone were to be splashed with lava, the absolute first step is to get them away from the source of danger, and get yourself away too. Once you are safe, call for emergency medical help immediately. It requires professional medical intervention as soon as possible. The next step is to cool the burn, but this is extremely tricky with a lava burn, as it will be fused to the tissue and you will cause more damage. The goal is to cool the area around the lava rock to prevent the heat from spreading further. Use cool water, not cold or icy water, for at least 20 minutes. While cooling the burn, it is important to take steps to prevent shock. Have the person lie down if possible with their legs slightly elevated. You can cover it loosely with a sterile, non-stick dressing. Do not apply any creams, ointments, or butter to the burn. A lava burn is one of the most severe injuries a person can suffer. We have been on quite a journey, from the dramatic image of 2 drops of lava, to the hard science of what they would do to human skin. The main takeaway from all of this is a simple but profound message: respect the power of nature. Volcanoes are not theme park attractions. They are living, breathing geological features that operate on a scale and with a force that is difficult for us to comprehend. They are beautiful, yes, but they demand our caution. When you see videos of people getting daringly close to lava flows, remember the invisible dangers. The ground can be unstable, new fissures can open without warning, and the air can be filled with toxic gases that you cannot see or smell. The safest way to experience a volcano is from a designated viewing area, at a distance recommended by local authorities and scientists. These experts understand the volcano's behavior and set up barriers to keep you safe. Trust their knowledge. Your safety is more important than getting a slightly closer photograph. Science allows us to understand these powerful forces. Geologists use seismometers. This science saves lives. So be curious and keep learning about our amazing planet. In the end, the story of what 2 drops of lava can do to your skin is a lesson in humility, because science is cool, but safety is even cooler.